Okay, Assalamualaikum and good morning to Mr. Muhammad Afi Bengasno and Mr. Zuhairi Batman. Today, I would like to present about my project, development of eddy current as a sensor to detect crack on metal. So, basically the introduction is, basically non-destruction techniques are popular in the industrial sector and wish to measure the properties of a material without damaging. One of the most popular non-destruction techniques is eddy current, radiography, ultrasonic and penetrating tests. Eddy current that flows through the prism is like a circular pattern into the conductor. It was generated by modifying the magnetic field and radiating parallel to the direction of the magnetic field through closed loops. This is because when the metal passes through the magnetic field, the eddy current is generated by magnetic field or by the direction diffused in the conductor. The effect of eddy current is equal to the output of the magnetic field, the circuit area, and the strength of the magnetic field, and inversely proportional to the resistance of the conductor. So the problem statement of my project is, the reason why I create my project is because the limitation human ability to identify the flaw in metal. Because with the human naked eye, we hardly to detect and inspect the flaw of material or metal that has crack or not crack. Secondly, it's difficult to determine the power dissipation during crack or non-crack metal plate. When in the theory, I see when any crack or happen in the metal, there is a power losses in the metal. Thirdly, determine the generating scalar of eddy current in metal block in COMSOL Multiphysics. So when the magnetic field infused with the conductor, they are generating circular of eddy current in metal block that you can see in COMSOL Multiphysics simulation. So let's move to the objective part, which my first point is I detecting a metal crack on metal using eddy current testing using COMSOL Multiphysics simulation. So my second objective is to study heat power losses occur in metal block in COMSOL Multiphysics. And the last one is determine the generating scalar of eddy current in metal block in COMSOL Multiphysics simulation. Okay, for methodology part, there is a project prototype and a flowchart. First, we go to the project prototype. Okay, as you see in the figure below, I use COMSOL Multiphysics that require quite a block dimension, which size width 60 mm, height 10 mm, and length 100 mm, and a cylinder which act as a edge current or coil to develop a magnetic field that infuse into inductor. The wire current is about 24 kilo ampere and running at 50 Hz. So as you see below, this my modeling in COMSOL Multiphysics, which the cylinder is act as a boundary condition to demonstrate the magnetic field and air inside the cylinder, and the block acts as a plate substance, which I will various the type with three type, straight line, zigzag pattern, and parallel line. So here are the flowchart of my project. We begin with start and select physics and study into the model space, and design a geometry for boundary condition and test substance. For boundary condition and test substance is like the figure like I mentioned earlier. Then we'll assign a geometry for each geometry. So basically we use to make it two geometry, which boundary condition will I use as air, and The plate substance I will set as a copper. Then create a free tetrahedral machine. Tetrahedral machine is a mesh to machine that need to be complete before simulation start. Then try to running. If there any problem, I will repeat to design a geometry back. So the process will repeat until there are no warning show. Then after there are no warning show, I will start the computation modeling. So normally the computation, my first computation starting about require about 1 hour and 3 hours. After I do some troubleshoot with my modeling, I able to finish about 2 minutes. Then after the competition finish, if the result shown, then the summation is done. Okay, for result analysis, here is table that I table the type of crack pattern, which the head length and width are equally sized with 10 and 7 and 5 millimeter. So for the plate A straight line, here is the result. As we can see, the top of the plate show the heat dissipation on and dissipation of power loss and the circulating generating eddy current. As we can see, the heat is concentrated in the middle part of the crack, which is most the higher heat losses compared to the other three crack. Okay, on the second plate is plate B. The plate B is the crack pattern is a zigzag pattern. As we can see, the heat losses also concentrated in the middle part, but this one is really straight line with the pattern of the crack. And the third one is the plate C. The plate C, there's a parallel line. Why I call it parallel line? Because it parallel with the edge current, which I can see when we place the crack into the parallel line with the edge current, the heat losses are be to the minimum heat losses, which detect the lowest losses compared to the three other figure. As you can see, there are only the vertex part of the crack only detect heat losses compare three of the figure. So figure below show the pattern of the generating eddy current inside the metal block. The eddy current, the pattern of the edge current move towards the crack. This normally happen inside the metal plate which have crack. So this a table that I got from the figure above, non-crack and crack. So this heat dissipation is unit is joule. The first a straight line, not crack is 2.5 times 10 to the power 7 and crack is 3.0 times 10 to the power 7. The zigzag line is 275 joule and crack is 350 joule. The parallel line is 0 until 0.5 times the power of 7 and 1 times 10 to the power 7. Okay, before we move to the conclusion part, I see how to I demonstrate the solution that I do in COMSOL Multiphysics. So I can see here's the design that I create from COMSOL Multiphysics. So let's move to the first part of the project. First part is I create the geometry. First is boundary condition, which the radius is 15 meter and the height is 10 millimeter. So the function that I create modification is to demonstrate the air inside the air, like the air lah. This is the air that will interpret with the metal blocks. So the second part is I create the wire using the laser polygon. The wire is to create the edge current in the middle part of the cylinder. And the third one is plate. So basically the plate is I using Fusion 360 to create a 3D diagram and the crack in the middle. So for the material part, I use two material. The first one is air, which in the boundary condition, and the second one was copper in the plate, metal plate. So I use magnetic field, act as a study to the my modeling, and I add edge current, which edge current act as a normally as a coil or as a coil that will pass through the cylinder and will be conducted inside the cylinder, and we integrate with the metal block, which the edge current is 24 kA. So before I move to the simulation part, which start to compute, we need to do free tetraeder meshing. So in the free tetraeder meshing, here is a plate. Inside the plate, as you can zoom here, the plate. Okay. So for maximum element size, I'm assigned as 0.8. So basically, maximum element size is the minimum of size in the plate. So the minimum size in the plate is the crack, which is 0.2 mm. But I increase a little bit, about 0.8, which will make meshing is more accurate. Okay, for mesh boundary condition, I mean the outside the cylinder is the maximum size I set to the 1 mm, which will be great to because the size of the cylinder is and the design is more like a round shape, and that no need to be complicated and will reduce my competition time. So for the study part, I use frequency domain, which I set 50 hertz. I set 50 hertz to the edge current. So let's begin. Okay, for conclusion, I can conclude about my project. First is the result was inexplicable, which show the heat dissipation and generating circular eddy current inside the block. I found that the parallel line produced least heat dissipation because of edge current was parallel with the parallel line. Okay, for the hardware that I cannot done in this project, this is because of there I need some more research about the material that need to be used, and the time is not enough to complete because there are MCO and other problem that need to be solved, and there are not need enough time to be complete. Last but not least, I would like to thank you for taking time out to listen to my presentation. I hope the presentation was clear and enjoyed. Thank you.